Well, welcome everybody to episode 13 of Community Cloudcast. My name is Eric Sheps. I'm joined by my fellow host, Paul McCollum, and our special guest for this month, joining us again, Drew Minkin from Divergence Academy. Drew, welcome.
Thank you. It is an honor to be here again.
Well, it's good to have you back. And so a few things before we get started. We're changing things up on you a little bit this month going forward. With everybody's schedules, it's very difficult to do a live show and also hard to get a lot of our overseas compatriots in on the conversation when we have a U.S. time-based show. So we've changed it up. We're going to pre-record our episodes and release them on or about every third Thursday. This will also give us the opportunity to create more content, capture content at conferences, and just various ad hoc conversations when we can have them and release them on just whenever we have those things available, put them out across all the social channels. So we think this will be a good switch to give you better content. The interaction can still happen in the comments on our YouTube channel or on Facebook. Please feel free to post any questions. Drew is going to deliver you a fire hose of information today, so I'm sure there will be some questions that will come back from that, and we will facilitate that conversation and get the feedback. So we want to make sure this is a live and ongoing conversation, as well as we'll have a new announcement coming next month. I've kind of been hinting at it for the last couple of episodes, but we'll have a new announcement coming where we'll have a more interactive forum and format with some other hosts joining us as well in a little bit of a different type of format that allows a lot more collaboration. And so we can also extend these conversations from the shows into those. And when we have a good one, we'll invite our guest presenters back into that forum as well for additional conversations. So as always, you can find us on our YouTube channel. Link posted here on the slide and in the comments, and as well on our Facebook page at facebook.com/communitycloudcast, or you can hit our website at communitycloudcast.com, get a list of events that are scheduled coming up and ways to interact with us and leave comments, etc. So with that, just want to say a big thank you again to our special guest, Drew, for joining us again. After our last conversation where we had a whole lot of content packed into a very small amount of time, thought it'd be great to unpack that a little bit and come back with some more architectural level type of conversation. So we want to thank Drew for joining us again. Drew, how can people find more information from you if they want to get more info or learn more about what you're doing or even have questions?
Well, thank you for that, Eric. I have my email address on the first slide, so you can always reach me there. Right now, I'm not looking for outside work, even though I'm a contractor at Divergence Academy. We are in the process of getting accredited to become a .edu, and so I'm looking to ultimately convert to full-time employee at that point. So that email address should be around for a very long time. So yeah, that's probably the easiest way.
Awesome.
And
very good.
Thank you.
All right, so just want to thank our sponsors real quick. As always, thanks to Aptident for sponsoring this channel and bringing all of our content to you. As I mentioned last time, working on some back-end stuff. We have some new releases queued up with some cool new tools for Power Platform and Nintex IBM developers et al. With some really big Salesforce releases coming as soon as I can get all the back-end stuff done. And converted over. So that'll be happening this fall. And then I'm hoping to get the Salesforce bits out by the end of the year. I think we have another 40 actions or so coming to our Salesforce tool set. So that'll be a really big update for that. So keep your eyes peeled. You can always hit www.aptident.com or look for us at conferences and whatnot that are coming up with for some additional conversations. So our conversation this month is navigating the data platform jungle, which is really taking things up, I think, a step from where we had them last time. We got into the weeds a little bit, maybe take a bigger picture approach from there. So I am going to, without any further ado, flip it over to Drew to intro and take us into the topic. And of course, we will ask questions, assuming that Drew doesn't completely blow us away and we actually have something intelligent to say as part of this conversation. We will make our contributions as we can. So Drew, all you.
All right, thank you. Can you see my my first slide now?
All good.
Can, yes.
Fantastic. Okay. All right. So again, there's this does have some technical background. So you know, in some ways, in unpacking one type of jargon, you may be trading in for another set of jargons. But in general, the idea is to take some basic concepts of just app dev and enterprise data 101 and try to establish those early so that as we start to look at essentially I basically have two big sections that we're looking at here. The data in context is going to just kind of frame some of these sub processes that we're going to talk about, right? Like if you're coming for data governance, data catalogs, the data integration nooks and crannies, then you should stop now, because the main things we're trying to contrast are data infrastructure and data strategies as far as two particular topics that in some ways are new things rebranded, and in other ways are relatively new technologies, just depending on how you want to look at them. So then there's also a little bit of a discussion about, now that you've looked at this vocabulary and try to understand what to do and how potentially you can use some of these technologies, that you can start thinking about what's necessary for your particular organization. And again, while I have been in the sales chair, either to venture capitalists or to potential customers in a product capacity, I am coming to you as a very cynical, grumpy old man of trying to cut through marketecture slides, as they call them. So
now that we could relate to.
Yeah. I was actually going to jump in here. You're a little too humble. So just so everybody knows, they are at the feet of the master guru. When I met Drew 17 years ago ish, he was part of the engineering team on SQL Server itself, before moving into the very nascent predictive analytics space and venture space. So Drew has of data analytics and all of our background architectures that we're building everything off of since early days. So I'm very proud to have been able to finagle him to speak for us, to speak with us.
Thank you again. My resume is not going to necessarily help anybody except for a very expensive dollar an hour. So I'm trying to put this into context where somebody who is getting sales calls and buzz feeds and things on jargon might be able to scan through the deck and say, okay, I get the big picture, and now I'm kind of forewarned and forearmed is my goal. So if you feel like you can have a more critical thought about what a vendor is trying to tell you, I think that I've done my job. So anyway, but thank you for that part. All right. So again, there's a little bit of background, and by a little bit, I mean I've got a total of 41 slides, and we're going to do just a real quick understanding in sort of current generation data from an enterprise perspective in 17 slides here before we get into the nitty-gritty here. Because like I said, if you don't get the basics of what is the new thing, what are the new things that everybody is repackaging and saying is their own shiny thing, then you're missing out on kind of you're victim to the sleight of hand of product teams that may do things that you ultimately may regret. So anyway, just wanted to give you that look there. So we're not going to be talking about all of these verbs in detail. This is more to understand that behind every solution, regardless how magic they call it, these are the 4 layers that I use in my class to teach students, people who are ex military foresters or snipers, to be able to become data scientists, right? Because ultimately you can break everything down into these particular layers, right? So just in case we haven't seen these before, like I said, we're starting with simple things here, right? At the end of the day, these are the main tiers that we look at. We're pretty much going to be focusing on the data tier for excuse me, this presentation. But the main thing was just to kind of establish a kind of visual vocabulary for some of the content that we'll be working through. And when we're looking at the excitement and also the problem with data in general is that it's easy to have things that generate data, and it's easy to put a web page up, that it's that icky middle that we spend most of our time on. And so in the terms that I'm using here, we'll talk about data engineering as a general class of work. And so essentially anytime somebody is telling you that you can see a report or something that doesn't look anything that's directly like how it is created, somewhere behind the scenes, this process is happening. Whether you call it a data warehouse, a data lake, a data lake house, a data store, a data set, a data mart, doesn't matter, right? It's all essentially this same type of architecture. So just want to establish that part. And then as far as the kind of next layer, once you have those, is where most people spend their time either in what when I first started, it was called business intelligence. Nowadays, people just call it analytics. Sometime in between, for a decade, it was called business analytics. And in a lot of cases, if you have the title of data scientist at a startup, you're really doing this without machine learning a lot of times, because then they have fancier titles like research scientist or theoretical data scientist, what have you. But the idea here is that you have data that's in some raw place where it's generated, usually that data in motion, and then build it into something that you can then ultimately use to answer a business question, right? And this is important because in order to understand why there are these new types of technologies and new jargon, you have to understand sort of the history of just enterprise data. And it was very difficult, very painful to be able to get reports for business, right? That's not necessarily our problem these days, but just giving you some background in that respect. And again, I could spend a whole hour just on this slide, but the main thing to understand is that there is no magic, there is no perfect algorithm that gets you something that can help you have a business result that's meaningful. Every algorithm requires a significant amount of data, right? But the rule of thumb is usually 10,000 cases or rows or samples in order to be able to get something that's meaningful. Sometimes you can do it with a little bit less, a lot of times you need a little bit more. But this is, regardless of what people say AI is, at the end of the day, what type of data it's using and what type of results you're using can all be boiled down to this kind of process in that respect. But when we think about how most people think about the data engineering aspect, or just the pure data part, right? We are still building on this fundamental truth, right? This has kind of been around since the 70s, right? The third null form, relational entity relationship diagrams, primary key, foreign keys, right? This has not gone away in this world. The problem is that this is kind of the bedrock layer of all of the enterprise data work that we do. And, at some point you end up having this context as a big sort of contrast between the data in motion of what actually is where things are being stored, that are being accessed by applications being written to in real time. And I would also include things like streaming data for Kafka or Flink or anything else in that kind of data motion traffic. And then ultimately, to be able to have a business question answered, you have some integration in data rest. Okay, we're going to talk a little bit about the data at rest, data infrastructure pieces to help decompose what we talk about between data lake, data warehouse, and data lake house, because those are the ones you see the most kind of traffic about. And I'll be poking some holes in some of the marketing information later on that as well.
So Drew, I have a quick question.
Sure.
You had the earlier slide where you showed the reports on one end, the visualization on one end, and sort of the raw data on the other end, and the transformational, that one right there, with the transform and load in the middle. In your experience, do you think that a fair number of teams, organizations, companies, what have you, underestimate the amount of effort that's involved at that level to really produce good visualizations? In other words, they're trying to shortcut it and get right to the visual and not thinking about how much work actually goes into that sort of middle bit of process there?
Yes, and I mean, here's how I describe it, is that there was a time where being a business intelligence developer meant that there was a dedicated subset of teams that were worried about managing a data warehouse as the end product that did things that, there are ancient techniques that I don't really go into in this thing called the Kimball method or the Inman method of how you build slowly changing demands and all this kind of archaic stuff, right? That's essentially, before Tableau, and I'm not blaming Tableau out of this, out of any enmity towards it or antipathy. It's just that, Tableau was a reaction to there being a difficult layer of transform to get to a visualization. You can argue that they kind of, with a good cube, which had sort of the transform mode analyze stuff in it, they made it much easier, or a good data schema, they made it easier to get to the visualization part and essentially created self-service BI. And so, but what's happened with self-service BI, there's been a bifurcation where at the same time that self-service BI was coming out, the data lake became, like big data came out and having the data lake, right? So what happened is that essentially the middle the idea is that there's a budget constraint of having people that know domains and can get reports into business people's hands on one hand, and then another group of people you just slide pizzas under the door and get data out from, that were handling all these weird data types in this new architecture, and being, learning how to do data science on things like text and images, things like that. So essentially the middle of the analytic expertises, you had a choice. Like most of the people who I know who at one point called themselves BI developers have either now become data engineers or become data scientists. And so what's happened is that since data science doesn't have a respect for a repeatable process as far as an enterprise data piece, because that's like that's not the thrill, right? That doesn't show an ROI. It's boring type of engineering that as an expertise has fallen out. So like right now, that's become basically the high-end data engineers are now doing BI engineers of building repeatable processes for data warehousing. And there's a shortage of those people, because it used to be that basically all the people who knew how to do that just started learning algorithms, and then they build them one-off to support their data science work. So that's been my observation over the last 12 years or so in the industry. But it's an excellent question. Thank you. All right. So again, we're going to be spending a little bit of time talking about data at rest, but I also want to talk about some of the kind of funner things that happen with data now that we are in the world that we are, right? Because it used to be that the only data that we cared about was tabular, or what some people call structured these days, right? So I've in looking at models that at one of my startups we were looking at doing was looking at this cognitive task mapping as being able to understand essentially layers of meaning. You can argue that on the macro level, these map very closely to the same process that we saw, but you could also look at each of those feedback loops as being something where there might be a new data source, a new transform, a new report that's being generated. But essentially, it's a general hierarchy of those types of tasks. And this is important to understand what the new generation of products for data that are coming out are doing behind the scenes, right? Because this is kind of implicit into kind of the next generation of data problems that are trying to be solved here. And this is kind of just another way of looking at the types of the level of business value and level of complexity that maps kind of directly to the hierarchy of needs for what's happening in an organization. And the closer you can get to optimize and predict, the less human intervention is necessary, at least on paper. But remember, like I said, every machine learning model has to be built by hand. And if somebody is not giving you a way to see how the sausage is made, you have to be skeptical, because you're going to need you're going to have to pay a consultant to customize things to get your stuff working great with their expert model, or they don't have a dog that will hunt, so to speak. So And again, I'm not going into too much detail about what's happening, but this is just kind of a basic example of how how nowadays people look at combining things from analytic models, things like data warehouses or cubes, or you know, Power BI data sets, Tableau databases, those type of, you know, higher level aggregations, and put them essentially to be able to be in a shape that can then be used for AI or ML operations. And I just add this particular slide as just another view of the same, because this is kind of an example of, we had one slide that already showed us the same process. This is an old one on the left-hand side. It's like 20 plus years old. And then this is the newest one that Microsoft came out when they got serious again about 6 years ago in Azure machine learning being a real product here. But again, you know, the most important thing to understand when people start dangling an AI shiny thing in front of your eyes is that this is from a very famous paid report that Google's AI teams generate, and each of these blocks you can look at as being an approximate percentage, kind of like a tree map of the actual layers of tasks that are involved in the analytic assets that are generated when you do ML. So in other words, your algorithm may be great, but it's just it's the tip of the iceberg from an application standpoint, right? This is one of the reasons why machine learning requires a lot of resources to be able to do well with. So anyway, we've done enough as far as giving you an idea of kind of the big picture of all the different processes, but there's one other thing that I want to talk about a little bit, because what we look at is data. We've been mostly really talking about relation with just a touch of machine learning as being something that we talk about for advanced analytics. But the reality of what data is being generated by today's applications, it's much more complex than it used to be, right? So this is a slide that talks about the different layers of a data ecosystem. I'm going to call it an ecosystem for right now, just to keep it jargon free. But the idea is, you can see there's sort of three big layers that people look at, right? You know, this one is a little bit confusing because it has edge computing under cloud and also cloud under edge. But you know, it's also kind of relative, because an edge computing might be something that is outside of the cloud. Could be an IoT hub, you know, that's in the field collecting data from a pump. But you know, the main thing to understand is that these are sort of the big components that we look at, right? And so we're going to try to unpack some of these together today to make it a little bit easier, right? We could probably do a whole talk just on this vocabulary and examples and stuff, but I'm trying to get to the main jargony stuff, because there's a lot of terms I've been hearing in the last couple of years while I've been out of the startup game that I had to unpack for doing this presentation. So the first thing I want to point out is that when we look at, we normally think about a relational database management system, right, where there's a row and table as being the main thing that is being stored. But the reality is that nowadays there are a lot of engines that support other types of interactions. And I also will note that just because this slide mentions, some particular products, I would not look at these as an endorsement in my personal view. This just happened to be the best high-res solution to try to give you an idea of the examples that we have to look at here. So you know, in that respect, you know, it's a good taste of what they have. I mean, key value pair is a very simple type of structure. Redis would be the main open source value that I would recommend talking about along those lines. But you know, it's a very simple structure, and it's used mostly by apps as a backend part. Document based is a little bit more complex, because you know, a document could be JSON, a document could be XML, it could be HTML. Anything that has sort of a root tag or root structure that you can navigate, you can usually use one of those types of parsings to be able to manage it, and also things like MongoDB, where things are stored in document collections instead of tables, but can still be sort of flipped into a SQL mode. Like, for example, CouchDB supports an ANSI SQL syntax as well as a core syntax of NoSQL style. And, you know, column-based or sparse is something that's designed essentially, the way to think about it is that, you know, basically for a while, the first generation of these were the cube engines that were in Hyperion and analysis services and SQL. And nowadays, most RDBMSs actually have a columnar store. That's a different way to be able to use things. So the idea that it's kind of separate is, I think, a little bit false, but there are some that are designed to be very large scales, like big data and, you know, Cassandra. But Cassandra also has a SQL, like a CQL, Cassandra query language. It's very similar to SQL. And then graph is, again, one of those things that you could, in a lot of times, this is a different mode of looking to the same NoSQL things. But I just wanted to kind of let you know that the main thing is that there are a lot of different ways to skin cats on these things. And if you, kind of speaking to the enterprise architects or data architects there, right, you have to make sure that you are not getting lock-in for particular vendors along these lines, because some stuff may be more proprietary than others as far as your access to the stuff underneath. So that's more just as a a caveat in that respect. All right, and so again, just before we leave sort of our introduction to what we're going to be looking at here, and again, there's a lot of stuff that I'm not going to be reading directly on top of it, because I can see we're getting close to the halfway point in the presentation. But again, the knowledge graph is a key understanding of being able to have a metadata layer that is derived from you could argue that a knowledge graph is essentially a traditional analytic product that is based on looking at source data, right? It's not answering a report. It's giving you a completely different view of being able to go across lines of not only domains like we normally had with data warehouses, data marts, but also to be able to add application integration into the same layer, right? So some people call them ontologies, some people call them taxonomies, but again, this is a very critical point to understand what is the magic, the secret sauce behind a lot of things that we'll be talking about that people are going to be trying to do in the technologies that we'll be looking at.
Drew, can I ask a question from
please.
the previous slide?
Mm-hmm.
And this is a gap for me. When in the examples you've got used to hearing among peering here is Hadoop and Spark. Are those different structures, or are they just tools for manipulating the structures that are here, or third thing altogether?
Well, so the way I would look at it is that these are, the fundamental rule of big data, as particularly the second generation with Spark, is and even to Hadoop and some of it, but that you separate storage from compute, right? So Hadoop you think of Hadoop as your file system, and Spark as the main, like the .NET framework is, I think, a good cognate for it, because essentially you can do everything in memory in Spark that you would do on disk using old school MapReduce technologies right there. So specifically on that subject, document-based, column-based, and graph-based are schemas that you can infer as native objects. Like there's a thing called GraphX that's a way to be able to take an edge table and a node table and be able to treat it like a graph and be able to do, triangle counts and, influencer strengths, page rank algorithms, those type of things. The document-based is, again, something where, the Hive essentially allows you to be able to put your to query data that's in JSON files and materialize it into SQL, right? You can also export SQL into JSON as needed, right? And the columnar store is essentially, I would argue that essentially Spark SQL uses a columnar store instead of a table store, because going back to, I didn't talk about it too much, but just to kind of spoil some of, I mean, I love Databricks, I almost work for them. But this Parquet here, this Parquet is essentially an open source columnar store that's used mostly for relational data. But it's something that can, you know, support millions of columns, and it scales well. With the Delta Lake stuff that we talked about a little bit last time, you know, it can even scale for streaming backends. So I think that answers the question. Thank you.
Okay, thanks.
Cool. All right, so let me, all right, so let's get to the nitty-gritty. Right now, I'm not going to talk too much about the difference between data warehouse and data marts in this case, because, you know, structurally, if you look at how a schema is laid out in them, there are concepts called star schemas and snowflake schemas and all that kind of you know, that data warehousey things. Basically, you end up building structures that optimize the ability to aggregate queries is the short answer. So, and data warehouses are traditionally sort of the top-down architecture idea, where you have, this is like the first generation data warehouses, where there's one big data warehouse for your entire company. So some people look at this sort of, those are the dinosaurs, right? The Tyrannosaurus Rexes of analytic models. And then when Microsoft was the first champion of the data mart with the Kimball method, which is essentially saying, okay, look, just take what you need, use a smaller server, answer the basic questions that you need to, and then worry about building bigger stuff later, right? So we're not going to talk about that much as far as the difference between data mart versus data warehouse per se. But just to give you sort of a baseline idea, right? Structured data, like the enterprise, you know, when you build transactional database or database in motion, you're usually trying to optimize for having the fastest writes and the fastest reads. So that's why you normalize into different tables. But when you ask fancy questions, you normally would try to consolidate those into more object-oriented schemas, things called dimensions and facts. They let you slice and dice, kind of like creating an entire database that could be one pivot table in Excel, right? Is a way to think about the data, how a data warehouse needs to be built. And that's traditionally been just to support things that fit well into tabular data, things like charts, you know, pie charts, scatter plots, that kind of stuff in what we normally think of as BI, right? So in some ways, you could say that pure data warehouse and pure BI solutions kind of peaked in their complexity with Tableau in that respect, because Tableau kind of took out a lot of the muss and fuss of the BI process, and they forced Microsoft to abandon their enterprise style BI stuff to create from scratch what we now know as Power BI, just to keep up with it. So anyway, so the data lake was originally made to kind of fill an opposite problem, right? The idea was that they wanted to have infinite scale of production apps, and then the complex questions of data science they had to ask, it would take too long to be able to move the data into another location, right? It used to be you'd have like a staging server or an operational data store, sandbox kind of thing that people would write queries on, or have data warehouse. And so data just basically got too big. And so you had to put everything in one place, right? The velocity, variety, and volume that they had, and then had one set of tools using first Hadoop and MapReduce, and then ultimately Spark, to be able to access it. And primarily, you're using that for machine learning. You can technically, I mean, in some ways, it's not. It's being a little. I'm not going to talk about which vendor that this is coming from, but they're kind of being a little bit dishonest about Hive itself as being a SQL dialect that can run on a data lake. But anyway, so when we talk about a data lake house, right? The simple way to look at it is that it's a data lake where you build structures that would look in an ERD just like data warehouse, right? In other words, you are essentially, are you making copies of data? Well, yeah, you are, but in that process, you are also removing data that doesn't have analytic value, and being able to make it easier to be able to get answers without actual. I mean, there's still data movement in that you're writing things there, but the idea is that if you choose the right infrastructure, you can essentially be transforming rows that come in from things like Kafka and Flink and streams with only a few seconds of delay before you can actually run your BI type queries on top of it. And because it's happening in an environment that supports BI and machine learning because of Python and R integration, you can do machine learning on top of it, right? So it's kind of the best of both worlds is the main idea there. And
just from an understanding perspective, because what you're describing sounds a lot to me like the traditional transformation process has now been integrated into, it's almost like you've squashed the tiers together and said,
yes,
here's our traditional data storage layer and our model layer, but we're also going to put sort of real-time transformation into that, so that we've sort of cut out one of the steps. Am I understanding that right?
Yeah, well, you've cut the number of layers as far as apps go. Like, for example, this used to be happening on a dedicated server that was on a different machine with different storage than what was being written by the streams themselves. Okay, so what's happening is that these streams are writing to the same, instead of having dozens of different SANs and different disk admins for different business units, it's all in one ugly big HDFS location. And the idea is you're essentially reading out of it, doing the transform, and writing back into it, right? The brand name that Databricks uses for its use of Spark SQL on on DBFS is their version of HDFS or open source HDFS is called live tables, because they've taken things out of Python and now put them into SQL to be able to listen to a Kafka stream and directly write it. It's kind of like if they took, if they made a listener for Service Broker in MS SQL and then had to be able to write to ADLS in there. But you're right in that it's essentially, and what's different though is that because you only run these steps when you want to, the idea is that there's a one-to-many relationship between the where you store everything. Everything's that one big X number of partitions in your terabyte, exabyte, and Y number of servers, right? So you may have some servers that are writing continuously from apps to disk for data in motion, and then for doing analytics, you may just spin up a Spark cluster for 20 minutes, run some jobs, and have it spin down so that you're not doing dedicated. Because a lot of times the downside in traditional models was that you may have spotty capacity, right? You may overload systems, sometimes because there's too much going on at one time, or you may be underused. Like you may buy hardware that you're not using, 23 hours a day, right? This basically makes it allow you to do on-demand Spark instances as an example along those lines. So,
okay, makes sense.
Thank you. All right, so again, I'm not going to go through this detail here, and again, take some of its bashes as with a grain of salt, right? Because the reality is that Data Lakehouse is something that is being marketed as a new to be able to help differentiate Databricks in their kind of war for customers over Snowflake right now. I jokingly talked about a data lakehouse in July of 2018 to a guy that actually wrote books on BI stuff. So I can't claim that I came up with the term because I don't know the exact time people started using it, but it was kind of a natural way, because when I looked at what we were doing in our product, that basically we were using big data as the data source and then building things that we could query to do analytics and all those things. But anyway, the point being is that this is a good kind of detail of those, but I want to show in an architectural way, a little bit clearer way of understanding it, right? You're still, and to be fair, in a lot of what what the positioning in this document is bashing technologies without mentioning that they've updated, right? I mean, like SQL Server on a desktop can actually have an R engine running in it and a Python engine in it. But what's different is that you are using proprietary storage in SQL Server and a proprietary engine, as opposed to something that is an open source engine like Spark on top of HDFS as being, different. So, take that again with a grain of salt there. And then also just to, look at one of the things that they try to, and this is again a marketing piece, right? Notice they trademarked this concept of data future proofing, but this is a way of being able to tell you that you want to be able to add as much analytic value to the things you're putting through your ETL process, so that it ends up being able to be, it's that one of the mantras in big data is to write once and read many. So that way you're adding more need of what you're doing in each pass to touch the rows, but you're not having to go back and do them as often. And there's a lot of things that are all very interesting products that are very tangential to the jargon I'm trying to unpack here. But these are example, replication's been around forever, movement, and it's just doing things, getting things from one place to another. Data protection, confidentiality, and privacy, those are layers of kind of security you have in there. But one thing I want to just kind of posit is that they try to use this this definition of data lake versus data lakehouse versus data lake or data warehouse as a way to say how much they're better. But if we look at what how Snowflake architects itself, I would argue, because you can get things directly from S3 and potentially put them into big data as far as an HDFS support, which you can also do directly from Databricks, that in a lot of ways Snowflake is a data lakehouse. In fact, it's not in this version of their architecture, but they have added in new versions. You'll see that they're moving Python and Spark to be running inside their database engine. So the line between, they're essentially becoming much more data lakehouse in response to fighting with Databricks for mindshare there. So hopefully that makes it a little bit easier to understand at this stage the basic core infrastructure that is where people are trying to store stuff. But again, just being able to get the data in one place and being able to get it so that you can answer basic questions is not where the battle of the future is for mindshare, right? And that's where I want to talk about the next kind of. I'm mostly talking about two concepts in here. I have a little bit I want to talk about hubs and virtualization. That's a little bit easier concept. But this is what I'll be talking for the last few minutes of the talk here. So as an example here, this is I'm not going to share whose brand this is taken from, but I did document all the sources that I looked at, right? Again, and this is something that I want to make sure people understand, that this is a common, it goes by a lot of different names, and it's something you can build for free with an open source version of Spark, and it's probably going to have similar features to what you could do with the product without a lot of the headaches of setup and things, right? Because at the end of the day, you're building, it's a fancy, what we used to call a distributed view, or a SQL view, but it just happens to be something that you can access through a lot of other bell and whistle type approaches at the end of the day. So again, I'm not going to go through all of these details here, because in researching the stuff and trying to sort through marketing digs at other products versus what was actually real technology, I almost felt stupider from my efforts, and this was kind of a new concept. I don't know if it's because of my age or just because people are just using the same terms and trying to knowing too much about general products and where they're trying to make things be a little bit hectic. But I mean, in my opinion, the main idea is it's a question of the bells, and there's a spectrum Data hubs are a type of data virtualization. Right? The simplest data virtualization is making a table that has some sort of query to some other system, right? There's a lot of different, and then data hubs could be a whole app that has an index of every table and column and metadata tags. So you can, just put in the domain question and be able to know what's going on, right? This is what Microsoft's Purview is essentially trying to attempt, is become a data hub for anything that you're working with. All right, so I put this information more for reference for people that are be coming in later on this stuff, just so they can, kind of tie through, because I think that the next slide is the easiest way to explain what data fabric is versus a data mesh. And, one of the challenges is that you can actually use data meshes and data fabric in complementary fashions, right? Believe it or not, like 80% of what's in this deck was from one Gartner report about data mesh versus data fabric, because in 2016, they basically were hyping the data mesh, and then they decided to kind of repackage data fabric to capture essentially this metadata activation and accumulation of trust and this active idea. And essentially all the things that look like magic that it's doing, this active stuff that they say will eliminate labor, that will translate somewhere into some type of machine learning that's being done on your data, right? So that's why I had, the idea of the database having a that you have to understand that machine learning is a continuous process, and it can be a very painful setup process to make sure that you're that you know what you're getting into when people make promises, because it's very easy to make demos that look like everything is going to look beautiful, because when you have demo data you can beat up like it owes you money for days and months. It's very easy to make machine learning look very promising, right? So the first thing to describe is that where it's this is actually, let me go to the next slide, because the similarities, the stuff below it are the old definitions of mesh and fabric to talk about. But the idea in all cases, mesh or fabric, the idea is that it's specifically in the data domain. There's some type of management that's happening of having some sort of workflow that's associable. And you can see that from Gartner's standpoint, they think that there's a huge opportunity for mesh and fabric to be something that they can push on people, right? Or they can say will solve their problems, right? But the way I would describe it in simplest terms is that data mesh, in its simplest definition, is the trying to manage everything from one location that is essentially local and passive metadata management and orchestration. And data fabric is essentially the next generation, where these become more centralized, more AI driven, and become more active in the in the scope of what you're doing there. So anyway, so like I said, there's a lot of good information that you can go into that talks about the difference between the comparison contrast these big buckets. But the main thing to think about is that data fabric is really in its simplest terms what I would describe as AI based processes that work with a data mesh, and data meshes are the support systems that essentially are the sources for data fabric in its simplest method. So there are things that are data mesh projects for data fabric, and there are things that are data fabric projects for data mesh. So if you're, again, this is, there's a lot of squishiness in these terms. So just be, aware of that some vendors like to make up different ways of what they are versus somebody else. So be aware, particularly on startups, because startups are just desperate to be able to get their first customers to be able to keep the money, so they can raise enough money keep going with their dreams, right? And sometimes, they'll try to do things that they shouldn't do because they're under a lot of pressure.
So isn't a lot of this magic wand stuff that says we're just going to fix all your data visualization and make it all so you could take instant business decisions and it drives your actioning and all that stuff that they try and sell you? Isn't that built on a giant assumption that there's someone in the business that actually understands their data and how to actually coalesce that data into something usable? Whereas a lot of times when I work with clients, it's very quickly obvious that no one really understands the data that they have or even understands the business case that's trying to be solved.
Right. So, if you go back to our cognitive tasks, right, the idea, if data fabric is going to deliver on its promise, that means that you can essentially teach a machine learning algorithm your process, right? Which means that your process is documented, consistent with data, and automatable, right? Risk assessment for banks is a pretty narrow one because there's very set criteria. You can build one machine learning model that has a very simple linear regression thing so people can understand it. It can be regulated. When it comes to much more complex decisions, like whether you get to post things on Facebook or whether you're other types of more complicated governance issues, the idea the idea that you can teach a machine to be able to automatically actively look at your data and make updates, right? Those updates are based on it understanding your processes well enough that it can add that additional value. So I think that one thing I think would be that I probably should have put on here that helps kind of people understand is that there is such a thing called an analytic maturity model to understand exactly kind of where you are in the spectrum, right? Most businesses are being run out of spreadsheets and business connections from golf, right? In a lot of ways, in which case the idea of analytics is not only foreign, it might be antithetical to the worshiping the hero. Whereas, on very mature, very large organizations, their businesses may be so complex and so automated that they require machine learning just to be able to keep up with what they can understand. But that you can't get from one to the other, very quickly here. So yeah, I mean, I think that you're spot on in that the idea that even a mid-market company is going to be able to have data fabric solve their problems, I think, is an oversimplification of most analytic maturities, right? Because if they don't already have, because basically if you don't have a knowledge graph, you're gonna have to buy one, and or fit your thing into somebody else's proprietary one, right? If you have a knowledge graph, chances are you know enough about your organization and you have a mature enough analytic team that you may be able to pick your biggest problems, your biggest pain points, and knock them off one project at a time, and may not need these broad strokes, right? So good point there. All right, so I got a couple slides to just kind of talk about the work here, and one thing I want to point out is that, believe it or not, just to show you kind of how crazy the documentation is, this slide that we looked at earlier, this was used to describe data fabric, right? But it was, I'm not going to reveal exactly which one it came out for. You can read the sources that I pulled this stuff from to see what vendor you work with. And, it's not because I was looking at, they were a potential acquisition source for myself a long time ago when we were briefly looking at being a bioinformatics company. But it just ended up being interesting that they looked at this as a way to describe data fabric, which doesn't talk about anything being active or passive as far as kind of the core messages we're looking at. So just wanted to give you so like I said, even it was like I said, in some ways I felt a little dumber trying to put this thing in and remove the marketing messages, because it practically varied from vendor to vendor on some of these very generic names here. But there's when we look at what to do, the main thing is that there's really kind of 4 buckets that I thought were nice ways to describe how to look at evolving your organization, right? I mean, and I'll tell you that this evolution is happening in big places, right? I was at AT&T as a contractor when they signed. I think it was they expected over the next 10 years that it was going to be $3 billion of spend moving their Kings Mountain HCFS system. I think it was something like 100 and I think it was 1,800 nodes that you could use for compute on it. So who knows how many it was for storage, but it was enormous. And they've decided that they want to move to the cloud. I read something in putting together this presentation where it said that something like by the end of this year, they're expecting that 2/3 of all data will be in the cloud now. And so basically on-premise is becoming the minority nowadays. So these are the kind of the simple ways to be able to look at trying to get stuff to change. And again, a data catalog, right? If a data catalog isn't part of what you're building in your current infrastructure, when you look at that as kind of layers of how you can get to these higher level value adds, then you're not in a lot of ways you're not really ready to be able to help have a map to your data mesh, if you will, for data fabric to be able to to work with easily there. So those are the sort of the incremental paths, but there are sort of the bigger ones of saying, look, let's just do the equivalent of a bunch of CSV exports, and we'll rebuild in our new systems, right? These are much more radical. They're certainly much more prone to risk, but these are sort of the outlines that a consulting vendor used to outline sort of the spectrum of what people look at. And the reality is that if anybody is telling you there's only one way to do it, chances are they have skin in the game for the solution they're proposing, right? What I would tell you is that if people are serious about your business, then make them earn it, right? They have, if your project is important enough to that company, they will find a way to see if they can get you from a trial phase into a paid customer area, right? So just make sure that you are there's a tendency I've heard that CEOs sometimes have is the shiny thing phenomenon, right? That they have one thing that they care about. I did some consulting for an insurance company locally here that came back from a conference and said we have to get machine learning everywhere, and then they spent, I think by the time we looked at the lost time for instruction and my consulting fees, it was like $120,000 in I think 9 months, and I think they only got 2 models out of it because the managers couldn't spare the people, and managers actually got afraid that if they learned too much machine learning that they'd actually leave, and then they'd have someone that had to backfill. So anyway, different structure, different stuff. So again, the important part is that even though you may be able to cut through the jungle, that doesn't mean that knowing that there is the jungle out there is going to spell out something very specific that is necessary. But again, my suggestion is to tackle things project by project, pain point by pain point, before you actually make big decisions on the rest of the moves, right? If you have vendor lock-in and some kind of major partner that's giving you, putting a gun to your head to get some stuff in the cloud for some compatibility, they've already made the choice for you. But in all of the cases, just make sure that you are not just hanging on their every word. That you say, okay, if that's what you mean, let's see you in action before I pay you. I mean, you may have to pay for like a proof of concept or something that covers the labor for a mini piece, but again, just make sure that you're putting a brick in the glove, because you don't want to make it easy for them to get to get your money and then find out they can't do it, right? You want to fail fast in that stuff. So again, these are the 5 sources that I used for this presentation. And again, I thank you all for your time and your questions on it. So I will stop sharing now.
Wow, that's excellent. excellent amount of information. That was absolutely phenomenal. So
Thank you.
A lot of things to take away from that, but I think the one that really jumps into my head is the fundamentals haven't changed, right? There's still basic building blocks there at the beginning of your presentation that still have to be followed. And if you believe that any vendor can just wave a magic wand and make all those fundamentals go away, you're just fooling yourself and probably throwing a lot of money away in the process.
Yeah, I mean,
sure, there's cool stuff that can make it better, right? There's awesome new tools, but you still gotta dig the ditch, as it were.
Right, and you know, it's hard enough for most infrastructure to get to a data warehouse as a layer of analytic maturity, right? If you don't have a knowledge graph on top of that, you're not ready for any of the stuff that Data Fabric is trying to do as far as being an active way of being able to add value across your different domains that you love, right? Because if it's going to be active, it has to have a representation of your business that is clear enough to learn from, right? And so anything that's a gap between that magic and your part, I mean, you know, you can make a tiger disappear on stage, but only if you've built a stage that's ready for a tiger, right? So, you know, just
I can reproduce any miracle with enough prep time.
That's right. That's right. That's right. That's right. So, sort of the corollary to what Arthur C. Clarke said, right? If you give me enough science, I can make your magic.
Yeah.
Yeah. Well, really, really good stuff. And I'm hoping we'll get some questions out of this that we could funnel back for those who want a deeper level of understanding. From my own perspective, I've just sort of touched, not even nibbled around the edges of these things. So this is great to give me a better picture of how these pieces fit together. And I hope that our viewers got the same sort of experience. So that is very much appreciated. And of course, this is a huge topic. We could go on and on and on, and we will have Drew back in the future to talk more about this and dig deeper, or maybe even take it up to a higher level, as it were, from an architectural perspective. I'd love to have a data architecture panel, right, where we could get some different viewpoints about just data architecture and different views and bat those around. But we're going to have to close this one out. For this month. Just a reminder of some of the upcoming events. European Cloud Summit coming up in Mainz, Germany, 26th to 28th of September. This is a cloud-focused conference. It's different from the Collaboration Summit, which is mostly Microsoft 365 and Teams and whatnot. This is a lot of Azure. Google will be there. Be some AWS content as well. So this is much more for cloud practitioners. I will be there talking about Azure API management. And lots of great content, as well as on the 26th, there's a whole slate of pre-cons packed full with some really, really good and deep technical information. And plus, Mainz is absolutely beautiful. We're right there on the Rhine. It's just phenomenal location. So you don't want to miss out on that. A little closer to home, North American Collaboration Summit, easy for me to say, coming up very quickly upon us in October. And lots of other events and things happening as well. Again, let's wrap up with thanking our sponsors. Aptigent, Jason couldn't join us this month. Hopefully he'll be back with us again next month. But you can catch their bifocal BI show focused around the Microsoft BI stack. And of course, Paul runs the Dallas Salesforce developer group here in town. Paul, you have any upcoming events that you want to mention for or related to the user group?
Next week, we have Amit Chowdhury, who is famous for putting together tons of training content together on a channel called Apex Hours, and he's speaking on code review practices. So exciting, very dev-heavy topic for the dev group.
Very cool. All right, and we will see you all next month. Again, remember that these will be released pre-recorded and released as opposed to our previous live format. So we will send out notifications on all our channels when the new episodes are available. If you have suggestions for some content that you'd like to see covered that are at an architectural or solutioning level around cloud technologies, please drop us a line via one of our channels. You can hit our website at communitycloudcast.com and drop us a line there. We'd love to get your thoughts and ideas ideas so that we can structure that content to bring in the future. So thank you again, Paul, Drew, for joining us this month, and we will see all of you